Hello everyone, welcome to the new session of chemical reactions and equations. Let's understand factors affecting the rate of a chemical reaction. We know that the rate of reaction depends on some factors. What are these factors? First, nature of the reactants. Second, size of the particles of reactants. Third, concentration of the reactants. Fourth, temperature of the reaction. And last, catalyst. Let us study all these factors one by one. First, nature of the reactants. Nature or reactivity of reactants influences the rate of a chemical reaction. The concentration of a substance can be expressed in a variety of ways depending on nature of a substance. Increasing the concentration of a reactant increases the number of collisions between the reacting molecules. We know that the molecules which are present inside a substance keeps on collide with each other, and due to the collision, the reaction rate increases. Now, what are the nature of the reactants? First, type of compounds. We have studied that there are two types of compounds, ionic compounds and covalent compounds. Reaction that involve ions in the solution tend to be faster. That means ionic compounds show fast rate of reaction. Reactants that involve covalent bonds tend to be very slow unless they are combustible. So, the reactions of covalent compounds are slow with the rate of reaction. Second, phase of reactants. We know that substances are found either in the form of solid, liquid or gaseous, and these forms also affect the rate of reaction. Reactants in solid solution or gas form react much more rapidly than solids. Why so? You will see here figure A and figure B. In figure A, the particles or the molecules are compactly arranged, whereas in figure B, they are loosely arranged. Remember, if the particles are loosely arranged, the collisions will be more, so the rate of reaction will be also more. So, in liquids or in gases, the rate of reaction will be more. Third, the surface area. The exposed surface area also affects the rate of reaction. The greater is the surface area, the faster is the reaction. Usually, this occurs by grinding any substance into a powder or breaking into smaller pieces. It increases the rate of reaction. Second, size of the particles of the reactants. This is again nothing but the surface area. More or less exposed to the surface area depends with the rate of reaction. Smaller the size of the reactant particles, higher is the rate of reaction. The powder has a greater surface area, so there will be more successful collisions in a given time, resulting a faster rate of reaction. Therefore, smaller the size of the reactant particles, higher is the rate of reaction. Next, concentration of the reactants. Increased reactant concentration increases the rate of reaction. In concentrated solutions, particles are closer together. As the particles are closer together, means there will be more collisions. We know that concentrated acid generally reacts faster than dilute acid. You will see in this figure given. In figure A, the particles are less, and in figure B, the particles are more. More the particles, so there will be more collisions. So the concentration increases the rate of reaction. Next factor we have is temperature of the reactants. The rate of reaction increases on increasing the temperature. Why do so? Due to increase in pressure or temperature, more particles have enough energy to make the successful collisions. Since the particles are moving faster, there will be more collisions, which in turn increases the rate of chemical reaction. The last factor we are going to study is catalyst, the substance in whose presence the rate of chemical reaction changes without causing any chemical change to it is called as a catalyst. Catalysts typically speed up the reaction by reducing the activation energy. For example, enzymes are proteins that act as a catalyst in biochemical reactions. Often, a very small amount of catalyst are required to increase the rate of reaction. Here, we studied some factors affecting the rate of chemical reactions.